Hello, my name is Arslan Ahmed, and today I'm going to talk about my product for this video. Now, at the beginning of the competition, I set a set of criterias to ensure that my product would be superior and better than any other products. So, firstly, it has to be extremely affordable. Secondly, during the installation process, there should be no major changes. In other words, you don't have to put any new wiring or buy some special equipment or any of that kind. And thirdly, it has to work with existing technology, and also should be able to work with a technology which is being developed. In other words, if you had a if you had a fan and you have implemented our system where you automatically on itself when the temperature rises to a certain degree, and then you, for example, change the fan, you put a new fan, so you don't have to it's basically it's an effortless changing. You don't have to put any hard work into it to reconfigure the system. You don't need to do that, and should we also be able to do this with any future technologies. So in other words, it has to be future proof. Now, in order to complete or achieve these objectives, I needed the right components for these things. So after extensive research, I decided to choose a few components. My first component, which is perhaps the most vital, is the ESP8266. The ESP8266 is it's very tiny. It's a tiny device. It's programmable, and and also has built-in Wi-Fi. And perhaps the most biggest advantage, it's very cheap. It's only at $2. So what the ESP8266 does is that basically it's the main device, is the main component that handles all the controlling of the house, or your house, of course. So that's basically the main component, and that's what most of the work is being done on. Then now after this, we needed to do this 24/7. Basically, it's not a one-step process. You have to keep on repeating. So initially, at first, I thought that we should you just simply use a PC. Okay, but then I realized that's not really viable or lucrative idea, because firstly, a PC, it still costs some money. It still costs money, and also it takes in electricity and it affects your bills. And also, they're also quite bulky in some kinds. So I needed to find something that wasn't so big and was still cheap at the same time. Luckily, I found it. It's called the Orange Pi. The Orange Pi is only at $7. $7, and it's a PC. It's a fully compatible PC. Whatever you do on your computer, you can do it with the Orange Pi at $7. So the Orange Pi, basically what it does, it houses our broker system. The broker system is called MQTT, or MQ telemetry. Yeah. So the MQTT, what it does basically, it's basically a broker system where no matter how much devices are sending in data to the MQTT, what it will do, it will queue them. You can say prioritize them, and it will and basically sends these commands to the ESP. So basically, the MQTT, one of its great features is that it can work with nearly unlimited devices of any kind. It doesn't have to be any specific thing. It's not like it can only work with lights or fans or electronic appliances. It can work with almost everything. So what it does, as I said previously, is a broker system, and it just sends data to the MQTT to execute that command. So also, to ensure that we would be able to able for our system to work with any other system, we use Java based technology. Now here's a great advantage: almost everything is Java. So when we are using Java, it becomes independent. In other words, you could say that if you had Windows, or if you had a Mac, Linux, or Android even, you'll be able to work with them. You don't need to have only Windows or only Mac. You can use every single software or OS. So this gives us a great degree of freedom. Basically, this again fits nicely with our second criteria. It has to be able to work with devices, and there should be no major changes. So at that, because of the our Java based technology, coupled with the MQTT's almost near unlimited potential to work with basically anything and everything, we basically are able to allow our system to work with a near unlimitless amount of systems. No matter what product you give, no matter what appliances, any kind, you'll be able to work with it. Now, you may be wondering, like, we're talking about smart TVs. We have nowadays smart machines. So what happened if we had something a bit older than that, something like a mono TV where you have a controller? There's no smart TV, there's no all those fancy features. You don't get to use your fingers to control it. So how do we control those? So this is where it comes. Now, most devices operate like in two states. They have an on and they have an off. So almost every device has that. Even the old ones have that. So, but there are a few. There are a few. There are some that operate more than these days. Like take for example a microwave. A microwave, you can on it, you can off it, but you can also do more than that. You can set the time limit, or you can adjust it to what you're cooking inside. So these are different states. Now, take for example, if you had a mono TV or old TV basically, so now a TV, now those TVs, they have a remote. Okay, so now those remote, they run on 44 megahertz. So it's a very simple thing that what we do is that we just simply take a 44 megahertz transceiver and we send and receive data to the controller. So what happened is that basically now we are controlling the controller, and in turn the controller is controlling the TV. So we are now able to even control older appliances, not now modern appliances. And we could and also if we wanted to control less simpler things, okay, that only has two states, it's a very simple matter. I'm just simply just commanding them or scripting them to just on or off. So as I display all of this to you, with all of these advantages that we have brought into our system, I believe that we basically have near limitless potential to control almost anything, as I said earlier. So this here is a $2 magic. This is the ESP8266. The ESP8266 is, as you can see, tiny. This particular one has only 1 megabyte, more than enough to program it. it is controllable, and also it is programmable. And also another thing it has built-in Wi-Fi. Now the built-in Wi-Fi, what it does is that now existing home automation systems, you need a lot of wiring. Okay, but we don't need any wiring because we're just going to use Wi-Fi to control everything. And now almost every home has Wi-Fi. So basically, just because it has Wi-Fi, we eliminate the need for having any wiring at all. While the ESP8266 handles 90% of the work, this controls the 90% of the work. This is the Orange Pi. It runs on a Debian headless server, and it houses our system and the MQTT. As I said earlier, the MQTT is a broker system. What happens is that when for example, take a fan or temperature sensor. The temperature sensor sends its data to the MQTT, and based on its priority, it will be queued. Once its turn comes up, the MQTT will send the data to our system. So what then happens is that our system will check the data and see if the temperature has risen to a certain degree, or if it hasn't reached yet. So then you send back to MQTT with a command saying that if it has reached this certain degree, then open the AC or exit on the AC or on the fan, and then the MQTT will send that back to the temperature sensor and send to the ESP, and the ESP will execute the command. Now you know all the important components of our project, but you may be wondering the most important part, how are you going to control all of this? Present home automation, many of them require you to install a panel into your wall where you control everything, and that takes wiring and costs money. It also install it. So I thought that why we have to use these bulky panels or some remote control, and we can just simply use our mobile phones. Everyone has mobile phones. Tablet could also work too. So what customers would do is that they would have a user interface, something like this. So the user interface you can see here is where you control all your devices. Of course, you can control it automatically too, but this is where you control basically your device. This is your control hub. So I'm now going to show you a live demonstration of a light onning and offing. So as you can see, there is a light lamp over here. So I'm going to activate the light via my tablet through the user interface. So I'm going to press the button. I don't know if you can see it, but I'm going to on it, and the light went on. And I'm going to off it, and the light went off. Now I'm going to show you the same demonstration, but with my voice instead. To dispel any thoughts that this may be a fake, I'm going to show you as I on the light with my voice. So you may see here on top left, or my left anyway, that there is a microphone icon. So I'm going to press this microphone icon. Living room light on. And 1 second. As you can see, the light went on. Now I'm going to off the lights with my voice. Living room light off. And 1 second. Living room light off. As you can see, the light went off. As you can see here, this is my home model. So if you come over here, you can see that we've cut the side and we're showing you the interior. We're still fixing everything. We're putting like little furniture. We're still painting and everything. But what we hope is like this is the garage, and what we hope is that like if you want to, if your car, someone stole your car, you get an email saying that your car is stolen, your car is not there. And also one of the bigger things we're hoping that hopefully by the time when you see us is that when we like on the lights in one of the rooms, we get a message from Google saying lights are on. It's still a work in progress. We're still working on it, but we are making good time. So this is basically the home.